Hello, myself Aryan Garg, B19EE015.
Myself, Ankit Chaudhary, B19EE011.
So, in this video, we will demonstrate our work which we have made for the Embedded Systems course project. So, we have tried to implement TinyML library in Arduino, as well as we have made a hardware box which consists of Arduino, NodeMCU, and ultrasonic sensors. So, first we demonstrate you about the TinyML library. So basically TinyML library is used to create such machine learning models which can be embedded directly into the Arduino and low powered microcontroller devices, which consumes less energy, less computational power, as well as less bandwidth. So for this we have made a model which can convert any number into its sign value. So we will head to the code in which you can see that we have generated 1000 numbers between 0 to 2 pi and convert their values into their corresponding sign values. So in this graph you can see that the numbers are plotted according to their sign function. Now we will split the dataset into training and testing, and after that we will create a machine learning model. So after training that model, we can get the results in which we can see that the red dots are the predicted dots and the blue dots are the actual values. So in this, we can see that the model is uh, trained quite pretty well because the predicted values are almost overlapping the actual values. Now we have converted the actual machine learning model into an Arduino, into a low powered microcontroller based model, for which we have used TF-Lite library, which can convert a normal machine learning model into a microcontroller based model, which can use low energy and computing power. You can see that this is the model and we can also download it. But due to some issues, we cannot able to implement that model into actual Arduino because that TinyML library has some constraints, as it can be only implementable in only some specific kinds of Arduinos like Arduino Nano BLE based. But currently we have only Arduino Uno. So we have changed our plan and made an hardware box. Now we will demonstrate that box. Yeah.
So here we can see the hardware box.
Yeah, so this box you can see that it consists of an ultrasonic sensor, and inside it we have Arduino Uno and NodeMCU and an LED bulb which can be used as an indicator and a push button. So I will turn on the button. Yeah, so you can see that currently yellow light is blinking. Yellow lights indicates that currently the NodeMCU inside it is currently the node MCU inside it is used to currently the node MCU inside it is trying to search a Wi-Fi network. So it is lighted yellow. Now I will connect that node MCU with Wi-Fi. So you can see now I turn on my hotspot. So I turn on my hotspot, and you can see that the color of that LED will get changed after some time. 1 minute. Yeah, so you can see that the color of the LED is changed to red, which means that now that microcontroller is connected to the Wi-Fi, but it is not currently connected to the server. So now I will turn on the server in my laptop by connecting to the same Wi-Fi. Yeah. So this is the code of the server in which we will receive the data and do some pre-processing in it. So now I turn on my server. Yeah. So you can see that the server is successfully on, and you can see that the LED is indicated to green, and we can also start receiving the values, the data in millimeter, in centimeter, and in meter. in every 5 seconds that node MCU will send the data. Now you can see that currently that height is about 208 centimeter, which is like the height till my roof. Now I will put my hand in the path of the mic or the path of the ultrasonic sensor, then you can see that the distance is reduced to 11 centimeter. So thus the distance is decreased. Now I will move further down my hand, and you can see that the distance is reduced to 7. Now I turn off my server. Then you can see that the color will be changed into red, which indicates that it is not connected to the server. Yeah, it is converted into red. Now I will turn off my Wi-Fi. Yeah, see, I turned off my Wi-Fi network, and gradually its color will be converted into yellow, which indicates that it is now searching for Wi-Fi networks. So this LED can give user a indication that at what level it is currently connected to. So this is all our implementation, and I will show you the Arduino code. And we have written the Arduino code in a very user-friendly way. We have made a sensor ID because we are storing the data to a database. I can show you here, like we have a database using MongoDB in which we will save the data, and after that we have made a node MCU secret key which can be used for the proper authentication of the node MCU and the server, so that so that only genuine microcontrollers can send the data. This key is matched both the sides, and simply user has to put its SSID and password and the host port number and as well as the host IP address, and then it will automatically connect to that server. So and this is our report in which we have explained about the system architectures and the working principle of ultrasonic sensors and some specifications of our board, and about the circuit diagram, and this is all the indications. This is the back panel in which you can see that this is the node MCU, this is Arduino Uno, this is ultrasonic sensor, these are LED bulb, and this is the push button, and this is a sample Arduino code. So thanks.